We are graphing functions of the form ax squared plus bx plus c. If you have that x squared, that creates a parabolic shape. It's like a U shape. So what we want to do is we first want to look at the axis of symmetry. Now there is a property with any ax squared plus bx plus c function that which is also standard form. That's ax squared plus bx plus c is standard form. When it's in standard form, we can find the axis of symmetry by using negative b over 2a. So a is your ax squared, b is your bx, and c is your number by itself. We can take that negative b over 2a and plug it into the equation to get the y coordinate of the vertex. So we can find the vertex by using negative b over 2a for the x and then plugging that in to the y. We also have a y-intercept that is c. The graph is going to open up if a is positive and down if b is negative. Now, if you think of a positive person, they're always smiling and happy, and they're going to create like a smiley, happy face. And a negative person is going to have a frown on their face, and they're going to go upside down. So you can remember the way that the parabola goes by thinking positive. If a is positive, it goes up. If a is negative, it goes down. The y-coordinate of the vertex is the minimum of the function if a is positive. So if it's going up, it has a minimum point at the very bottom. And then if it's negative, it's upside down, so it's going to have a maximum point. Everything below it will just keep going down, 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 but there is one maximum point on here. Now, the lowest point or the highest point is called the vertex. So it's just the point where it comes to a head. Okay, here is an example. We have negative 4x squared plus 8x plus 2. So we're going to first find our a, b, and c. Our a is going to be the number in front of the x squared, which is negative 4. Our b is the number in front of the x, which is 8. And our c is going to be the number all by itself, which is 2. Now we're going to use our negative b over 2a to find our axis of symmetry. So if I take my b is 8, I'm going to find the negative version of 8. So negative 8 goes on top. Then I have over 2 times a. Well, my a is negative 4. So I take 2 times negative 4, which is negative 8. And I have negative 8 over negative 8, which is a positive 1. So that is where my axis of symmetry is going to go. So we draw just this light dotted line down the center at 1. And our x on the vertex, the x is always going to be on the axis of symmetry. So the x coordinate of the vertex is going to be 1. I need to find the y coordinate. And how I do that is I plug in 1 for everywhere there's an x into the equation. And that will give me my y coordinate of the vertex. So when I plug that in, I have negative 4 times 1 plus 8 times 1, and then plus 2. So 4x squared plus 8x plus 2. Now that 1 should be squared on that first one. And when I evaluate this, I can just put it in my calculator. I end up getting a 6 for the y coordinate. We just plugged it into the original equation. And we plot that point on the parabola. Now, there's 2 ways you can do this. If my c is 2, that is going to be my y-intercept. So my equation is negative 4x squared plus 8x plus 2. Now, whenever we're finding a y-intercept, what we're doing is we're plugging a 0 in everywhere there's an x. Because on the 0 axis, where x is 0, the y is our y-axis. So by doing that, we get the point 0, 2. So we have a 0, 2 on the left, and that reflects across the axis of symmetry, which gives us the point 2, 2. Now, the other way we can do it is by using the key points. Now, whenever we have x squared, we have the key points of 1, 1, and 2, 4. The reason is because 1 squared is 1 and 2 squared is 4. Now, our a is the same as the a in our last section, where we multiply the y by the a. So we are going to take 1 and times it by -4 to get -4, and 4 times by -4 gives us -16. Now, if we go ahead from the point 1, 6, we go over 1, down 4, that gives us the point 2, 2, which can be reflected over the axis of symmetry to give us the point 0, 2 as their other point. So we get the same points either way. Now 2, 16 over 2 down 16 is going to go off the graph, but you can also put that point in. Now let's just remind ourselves of this success criteria. We're going to identify A, B, and C. This is just like when we factored, those A, B, and C are the same numbers. We can find the graph of the axis of symmetry. The axis of symmetry, we use -b over 2a to find the axis of symmetry. Our x coordinate will be right on the axis of symmetry, and we plug that in to find our y coordinate. We connect them with a solid line, and we can use either key points or the y-intercept to find our third line. Let's go ahead and write A, B, and C for this first problem. A is 2, B is -8, and C is 6. If I use -b over 2a, I have -8 over 2 times 2 for our bottom. Now a -8 is a +8 over 4, which equals 2. So our axis of symmetry will be at x equals 2 on our graph. And we can just draw a dotted line in for that. Now our vertex, the x coordinate, is the same as our axis of symmetry. It's going to be on that line. So the first point we have is 2. Now to find the y, we're going to take that 2 and plug it into the original equation. So we have 2 times 2 squared minus 8 times 2 plus 6. Now 2 times 2 times 2 is 8. 8 times 2 is 16, and plus 6 at the end. 8 minus 16 plus 6 gives us a -2. So that is going to be the vertex that goes on the axis of symmetry. So we go over 2, down 2. Now we need to find an additional point. So we can do that one of two ways. We can find the y-intercept by putting 0 in for all the x's, or we can use key points. So when we put zeros in for all of the x's, we end up with C all by itself. So the 2 times 0 gives us 0, 8 times 0 gives us 0, and then we just have that 6 all on its own. So that point is going to be, we put a 0 in for x, and then we have a 6 for y. And we go over 0, up 6, and that will be 1 point. We can reflect that across the axis of symmetry and connect them with a smooth curve. And this would be the equation of our line. We can also use our key points to find it. You don't have to do both, but just pick one of these ways. This is the second way. We have the point 1, 1, and 2, 4. Our A is 2, so we're going to double those y coordinates. So instead of going over 1, up 1, we go over 1, up 2, and reflect it across the axis of symmetry. And we also go over 2, up 8, which is that same 0, 6 line that we had before. Now this says max or min. Now this is a minimum because it's down at the bottom. It's going up, it's the lowest point is the vertex. So it's a minimum at that 0, 6. Now we want to, next is our domain. Domain is any x values we can put in. we could put any number in for x. There's no restrictions. So it's going to be all real numbers. I can put a 1 in, I could put a half, I could put pi in, and I can get out a number. The range is not going to be the same. The range, if you look at this, it starts at -2. There's nothing below -2. But it's everything above -2. It keeps going up and up and up forever. So what we're going to say for our range is y is greater than or equal to -2. We put the equal sign because it is there. There is a point at -2. Now on number 2, we're going to write our A, B, and C, but we don't have a number at the end. So we're going to add on a +0. That 0 is the C. Okay, now when we find our axis of symmetry, we have -b over 2a. Our -b is a -6, and then 2 times our a is -3. So we have -6, which is +6, and 2 times -3 is -6. This equals a -1. So our axis of symmetry is going to be at x equals -1, and we draw a vertical line right there at -1. On the vertex, we know that it has to be on top of that line. So on the vertex, our x coordinate is going to be a -1. To get the y coordinate, we plug it into the original equation. So we have -3 times -1 squared -6 times -1 plus 0. So we have -1 squared is +1. So we have -3 plus 6, which is +3. So our vertex of this equation is going to be at -1, +3, and we plot our point there. Now we need an additional point. We can use we can put a 0 in for all the x's. And if we put a 0 into all the x's, we have the point 0, 0. So that would be 1 point, and then we can reflect it across the axis of symmetry to get the other one. The other thing we can do is we can use our key points. Our key points are the point 1, 1, and 2, 4, but then we times it by our a. Our a is -3. So we would have 1, and we times the second one by a -3 to get -3, or we have 4 times -3 is -12, so 2 -12. So we have the point from the vertex, we go over 1, up 3, and we reflect that across over 1, down 3, and we reflect it across, or over 2, down 12. Either way, we can get this nice parabola shape. Now we're looking at whether this is a maximum or a minimum because it has it's upside down. The highest point is a maximum. Okay, so it goes down forever, so there's no minimum point, but it does have a highest point is a maximum point, kind of like a mountain is like it has a maximum point. Now domain is all reals. Any parabola x squared is going to have all reals. There's no number that will cause this to crash. We can put any number in. Now the y, we look at where the y is at the peak. It's at the peak at 3. So it goes upside down, so y is less than or equal to 3. Everything below that 3 is our range. Problem number 3, we have g of x equals x squared plus 2x plus 5. Now, first thing we want to do is write down our a, b, and c. Our a is the number in front of the x squared. Now, there's not an x squared there, but there's always a number. It's a 1 if there's not a number there. Our b is the number in front of the x, which is 2, and our c is 5. Now to find the axis of symmetry, we always use the equation x equals -b divided by 2 times a. Our b is 2, so -b would be -2 divided by 2 times our a, which is 1. This gives us -2 divided by 2, and 2 divided by 2 is a 1. So our negative 2 divided by 2 would be a negative 1. So our axis of symmetry is that x equals negative 1. Now to find our vertex, we always take our first number on the axis of symmetry, and that is what's going to be we're going to put in for our vertex, because the vertex is always located on top of the axis of symmetry. So we have a negative 1 there, and to get the second number, we're going to take that negative 1 and we're going to plug it into the equation that we have here. So we're going to put a negative 1 in for our x. Negative 1 squared means negative 1 times negative 1, which is a positive 1. And then we have 2 times a negative 1, which is a negative 2, so 1 minus 2, and then we have a plus 5. Now 1 minus 2 plus 5 is a 4. So we're going to have the point negative 1 comma 4. Now let's go ahead and plot that point. Now our additional point we're going to get by finding the y-intercept. Now our y-intercept is always the point 0 comma c. Okay, so this is the y-intercept. So the y-intercept is 0 comma, our c value is 5. So we're going to have a point at over 0 up to 5. The axis of symmetry is right on top of that vertex. And then the graph reflects over the axis of symmetry, so it'll be the same on both sides. So it'll look something like that. Now this graph is pointing up. So it's kind of like you're in like a pit here. So if you're at the bottom of a pit, you're at a minimum point. So this is going to be a minimum. Domain for parabolas is always all real numbers. And then we want, for the range, we're looking at y values. The lowest point of the graph is at 4, and it's everything above 4. So y is going to be greater than or equal to 4. Now we are looking to see whether this function has a minimum or a maximum value, and then find that value. Well, since looking at 4, the a is a 3. So it is a positive value. So it is going up. So it has a minimum at, and to find that minimum, we use negative b over 2a to find the x value, and then we use that number to plug into the equation. It's just like what we were doing earlier. So we're going to write down our a, b, and c. Our a is going to be 3, our b is negative 18, and our c is 20. So negative 18 goes on top, negative b over 2 times a is 3. So we have positive 18 over 6, which equals 3. So our x value is 3. Now to find our y value, we take the 3 and plug it into the equation. 3 times 3 squared minus 18 times 3 plus 20. And you can just plug that right into your calculator. What you end up getting is negative 7 for the y value. We're going to do the same thing for number 5. We have a, b, and c. There is no c value. There's no number by itself, so we're going to add a plus 0 at the end for our c value. A is going to be negative 1/2, b is going to be a positive 4, and c is going to be a 0. So we have a, to find our x, we're going to use negative b over 2a, and then we end up getting negative 4 over 2 times negative 1/2. Now on the top we just have negative 4, but if I have half of 2, I get 1. But there's a negative sign there, so we're going to put a negative 1. The negatives cancel, and I just get a positive 4 for my x value. To find the y value, I take the 4 and I plug it in everywhere there's an x in the equation. So I have a negative 1/2 times 4 squared is 16 plus 4 times 4 is 16. And when I simplify all of that, I get negative 8 plus 16, I get 8 that I put in for my y value. Now because that a is negative, it points upside down. So this point, that vertex, is going to be a maximum point.